Okay, so what we're going to talk about today are a lot of just tips and tricks for working through a bunch of different debugging features in ChIDE that are frequently left off, such as working through the step function versus the next function, or setting up what we call breakpoints so that we can really easily debug to different points in our code. We're also going to talk a lot about how ChIDE is built to support you as you're writing various programs through different features like auto-indentation, autocomplete of commonly used variables and words or functions, some other functions that are less commonly used, like a shortcut to quickly jump to a matching brace on a piece of code, or for automatically inserting comments, or actually even getting into things such as defining our own preset pieces of code where we can just type in a keyboard shortcut and it'll autofill a chunk of code as long as we would like. So to go through all of these different topics, I'm actually going to start off by writing a simple program in ChIDE. So to open it, I double-click on ChIDE on the left-hand side of my screen, and it's going to give me a blank slate to work with. If you don't have a blank slate, you could click File, New to get a new one, but I already have one here. If you'd like, you're more than welcome to follow along on your own computer if you have it with you. That way you can kind of get some first-hand experience working with these different tools. So I'm going to go ahead and maximize ChIDE so it's hopefully a little bit easier to read. And then I'm going to go into View, and I'm going to change my font size, and I'm going to increase it to 20, so it's hopefully even easier to read the font as I'm doing this. If you have any comments or anything as we are going through this short 1-hour webinar, go ahead and put them into the chat. I have it up here on my second monitor to my right here, so I will see those. Another thing to note, if you do have any comments, we do have a 3 to 5 second delay with this stream video. So if I don't respond right away or catch it right away, that might contribute just a little bit to it. So the program that I'm going to write is, I'm going to say I have a link bot and I want to drive it in a square. So the very first thing that I normally do when I'm writing a program is I leave some comments. So I'm going to say this is file, let's say robot square.ch, and I will call it that in just a few moments when I save the file. And there's been a question. I'm hoping that I'll be able to make it available to view after the session, but this is kind of an experimental run with recording to see if it actually picks up everything that I'm hoping. So if it is, I will send out the link. If it's not, I will try and find another solution for the next time as well. So anyhow, continuing with my comments here at the beginning, I like to say a short description of what I'm doing. I'm going to drive the robot in a square. And then I'm going to end off my comments here. So to any time that I want to use the robots, I have to do the pound symbol or hashtag or however you refer to this symbol, and then I have to say include, then the less than and greater than, and I say linkbot.h, and then I have to declare my linkbot. So C linkbot I robot. And again, you can call this linkbot anything that you'd like. I like to use robot because it's consistent with all of the pre-written sample codes that we have. So once I've declared my robot, I need to start looking at how I'm going to drive it in a square. I already know a square is a really simple motion where I drive forward some distance, I turn either left or right, and then I drive again, turn again, drive again, turn again, drive again, and I'm back to where I started. So I could say robot.drive distance, and then I can give it the distance that I want it to go. Let's say I want the square to be 5 inches on each side, and the radius of the wheels. I'm going to go ahead and say I'm using a 1.75 inch wheel radius because that's the default that we normally start with. And then I can go ahead and do robot.turn. I'm going to make my square turn to the left. It doesn't really matter which way it turns. Each time that I turn, it's going to be a 90-degree angle. I have still a 1.75-inch wheel radius, and my track width of the LinkBots is 3.69 inches. Now before I finish off this square, I'm going to go ahead and save my file so that I can run it, and I'm going to set up my RoboSim environment so that you guys can see exactly how this code is running on my computer. So I can click on this save icon, and then I'm going to go ahead and save it on my desktop and call it robotsquare.ch. Now to set up RoboSim, I need to go back into CSim Studio and double click on RoboSim, and that will open up RoboSim here. And I'm going to go ahead and move forward with just the default options on RoboSim. So I have my robot here in the middle, and if I go to my Robots tab, it has the wheels of 1.75 inches, and it starts facing along the y-axis. And I'm going to keep this open in the background and minimize so that I can go back to ChIDE. Now one thing that's normally very helpful as you're working with a bunch of different windows is the Alt-Tab keyboard shortcut on Windows, which will pop up a bunch of all of the different windows that you have open, and then you can easily left click on whichever program that you want to switch to. So if I were to run this, my RoboSim is going to pop up. I can press any key to start it, and it's going to go through this really quick sequence of drive forward 5 inches and turn left. So I know this is working, and one of the most common shortcuts that we use when we are programming in any integrated development environment is copy and paste. So I can hold Control, hit C, that will copy everything that I have selected, and then I can hold Control and hit V to paste it. Now to move in a square, I need to move 4 times, so I'm going to repeat this 4 times, and then when I click run, we will see that my robot does in fact drive forward and turn left and go all the way around this sequence in a square. I'll just drag it over so it's a little bit more centered. And then it's going to turn to face the direction that it started. So this is excellent. My square is finished. Now, what if I made a mistake? Let's say here, instead of turn left, I accidentally said turn right, and when I run this, my code gets all kind of messed up. If I have a longer program than this, it could get really complicated really quickly to actually go through and figure out exactly where in my code this turn here was. So we can use our debugging features to navigate and fix this for us. So along the top of ChIDE, we have a bunch of different buttons, starting with Start, Continue, Abort, Step, Next, Up, Down, Break, Clear, Parse, Run, and Stop. So the one that most people use is the Run button. This is going to actually process this code and tell the robot to drive through following all of these commands. However, if you want to do this step by step so that the robot goes one line at a time, we have 2 different controls here that will allow us to do this. We have the step command, which is a little bit more complicated and we'll talk about in just a few minutes, but then we also have the next command, which will just run through whatever line we have selected, starting with the very top. So if I click next, it's going to automatically run through that first line, including the linkbot.h, and it highlights the next line green, saying this is what we are going to do next. So anytime that I click the next button now, it is going to move through that command. So since I'm using RoboSim, clicking next is going to initialize, it's going to declare our robot and pop open our RoboSim window. Now I'm going to drag it off to the side so I have the simulator open next to the code so you can see both. And if I keep clicking next, it's going to run through one robot command at a time. But you'll notice because my simulation is paused, it hasn't actually run this command until I unpause the simulation. And now every time I click next, it will keep going through the sequence, highlighting each command as I do it. So I can really easily use this as a way of finding where I went wrong in my code without having to read every single line down the list. And then I can see right there that command was my turn right command and it was wrong, so I can quickly go in, edit it, and keep going. Now imagine if I had this robot driving through this square, say 4 or 5 times, with slightly different sizes to the square. It could be quite a bit of work to sit here and click next over and over and over again to finish out the program. So another thing that I can do is I can click on continue, and this will say keep running through the program until it's finished. We're done debugging and we're ready for it to just finish out, so we can make sure that after this point everything else is okay. The continue button will also become a little bit more relevant in a few minutes when I talk about what we call breakpoints. There's also the abort program where you can stop the debugger exactly where it is, and sometimes this will cause a little bit of an issue where you might get an error message that pops up because it didn't finish the program or something along those lines, but it's just another way of stopping it, much like the stop button. So I only have 2 things left, so I'm going to go ahead and just click continue, and it's going to keep running through both of those commands, and it is finished. So, if I'm writing this program to drive a robot in a square, I may want to actually start to create some shortcuts for myself. One of those shortcuts is every single time that I'm driving the robot, I'm using the same wheel radius. So chances are I don't want to retype 1.75 all over the place. In addition, if I were to change the wheel radius of my robot, I'd have to change this 1.75 to 2 or whatever the new radius of my wheels is in a dozen or 2 dozen places. So I like to declare variables to store pieces of information that I will reuse later on. So I'm going to say I have a double and call it radius, and double is just the type, meaning it can store a decimal value. It's a double precision floating point value. And I'm going to say the radius is equal to 1.75. Another repeated value that I have is the track width. So I can say track width is equal to 3.69. And then I can finish my declarations here with a semicolon. Now, one thing that's really nice about the C languages while I'm at this point is they're not very picky about white space. And white space is any characters that are not drawn, that are just empty space, such as the return character, which is going to a new line, or the space character, which is literally leaving space between elements. So if I were to go on to a new line, I could keep this going, and then I could line up my variables so that I could have several variables really nicely aligned in a column here that's really easy to read. So once I've declared my variables, I could then replace all of my 1.75s here with the variable. Now that can take a little bit of time. As you see, I have, 7 more times of using the 1.75. So there's another tool in ChIDE where you can click on the search menu at the very top left here and select replace. And this is going to pop up a standard find and replace menu, and I can say find 1.75 and replace it with radius, and then I can select find next and replace over and over to go to each one. And that is extremely useful for if you have 2 robots and one is using one size wheel and another is using a different size wheel, or maybe you for some reason have another 1.75 value somewhere in your code that you don't want to replace. I already know that everything in this code I want to replace, so I could click on replace all. In addition, if I only wanted to replace a small section of the code, I could select a section of the code and do replace all here, and it would replace everything select replace in selection, and it will replace only the 1.75s in the selection. And actually, that would be the better option for me here, because my radius is set to 1.75, and if I did replace all, it will replace this radius as well. So I'm going to select here and choose replace in selection, and now I have radius across my code. I can then do the same thing for the 3.69 and replace this with my track width, and select replace in selection. I'm done replacing things. It even tells me how many places it replaced the value, and I can go ahead and close this menu. And then just to see that everything works exactly the same, I can click on Run and allow my robot to run through this sequence. And once again, I will center this a little bit better. And it's finishing up the last 2 motions now, and we'll see it was perfect. Excellent. So now another thing that could be very useful is, what if we wanted to drive the robot in a square multiple times? There's a few different ways we can do this. One of the ways we can do this is by using a while loop. And we could say while, and then say some condition, let's say x is less than 5. And this is just saying, as long as this statement reads as something true, it will keep running through this loop. So I say while x is less than 5, run through all of this. If I were to run this as is, the computer still has no idea what x is, so I have to say declare x. So I'm going to say int x is equal to 0, and I'm going to start off with x being 0. Now every single time that it runs through this, it's going to say 0 is less than 5, that's true, and it's going to run through top to bottom of my braces here. However, when it gets to the bottom, it's going to come back up, and x is still 0, so I have to make sure that I increase x. So in the bottom of my loop, or I could do it in the top, the location doesn't exactly matter as long as in top to bottom order it actually makes sense and will update before it gets back to the top of the loop where it checks. So I'm going to say x is equal to x plus 1. And now every time it gets here, it takes the value of x and increases it by 1, so that it will end up with a value of 5 at the end here, before it ends the loop. So this loop here will run through a total of 5 times, so that I get 5 squares. Now, for the sake of saving time, I'm going to replace this with a 2 and click Run, so you can see the robot's going to go through a single square once, and then repeat, do it a second time, and then get back to the starting position. And then after that, it's going to end the loop, and the program's going to keep going after that loop. Here it goes with the second square. And it'll stop in just 2 more motions here. It'll turn, and it should stop right there. Excellent, and it says pause, press any key to end, because we are done. So now, one thing you may have noticed is when I entered this x equals x plus 1, ChIDE put in this extra space here automatically. So when you're writing computer programs, making the code so that you can read it later on is extremely important. So there are lots of conventions that go along with how you should actually write your code to make it easier for you, your students, and anybody else in the future who may be looking at the code, easier for them to kind of navigate what's going on. So ChIDE has this AutoIndent feature where anytime that you hit enter on a section of code that it thinks should be indented, it will automatically indent to the next line. However, because we had already written all of these lines of code beforehand, it didn't automatically indent that to fix it for me. So what I can do instead is I could go up into the Tools menu here at the top left, and I can select Indent from the menu here. And what this will do is it will save my file and then re-parse it, creating all of that automatic indentation that I would expect to see automatically when I'm running through the program. And you'll notice it actually automatically indents several other places, like our spacing here for the while loop, my spacing here for my variables, to make it follow conventions so that it's easy for anybody else who is familiar with conventions to pick up on and read. So once again, that was the tools and then indent, and it will automatically indent all of our code there. Now, another thing that's really nice about these curly braces is the computer will tell us anytime that we have a expected end or an unexpected end to a brace. So you can see right now when I have my cursor at this brace, it turns it blue, and then it also turns the other brace blue down here at the bottom. And that's just showing where the matching braces are. Sometimes that might be a little bit hard to see. Maybe it's scrolled down, maybe you have a lot of code and you can't immediately see it right away. So there's another tool. It is up here in the edit menu, and it is called Match Brace. And this also has a keyboard shortcut of Control E. So it will automatically move your cursor to the matching brace for it. So if I click on that, you can see it jumped my cursor over. I can do that again, and it will jump my cursor back to that first brace. So it helps me navigate my code just a little bit better. In addition, we have another one that's Control-Shift-E, which is Select to Brace, which will select everything inside of that brace so that you could really easily copy it or move it or cut it out of your document, anything that you want to do there. So there's some really neat things going on there, especially when you start working with things like nested loops, or you start adding conditional statements like if-else statements, and you start nesting a lot of this together. You may end up with some indentation that goes 4 or 5 tabs over and then braces all over the place. And so this match to brace is very, very helpful for making sure that you've got your code lined up very well. Another thing that it does is, say I miss the end of this brace here, when I have my cursor next to it, it actually highlights that brace red so that I know right away that I haven't closed off this brace for the next, so that it knows where the end is. So then when I put that brace in, it now turns back to blue. So as my code is growing here, you can see it's still relatively simple to read, but maybe some of the things that we're doing aren't quite right off the bat intuitive. And so for future me, if I were to read this code in, say, 6 weeks, I would want to leave some sort of comments for myself. That way I can really quickly pick up on it in plain English exactly what my code is doing. And so I like to leave the 2 / comments so that it comments all the way to the end of the line, so that I can leave this really quickly anywhere on any line. And here I'm just going to say drive the robot in 2 squares instead of only 1. That way, if I were to look at it, again, in like 6 weeks, I can read this sentence and know right away that this loop is driving the robot in 2 squares. Or if I were to have this be 5, I could say 5 or whatever that I wanted to there. Now, another shortcut for creating comments is the Control-Q keyboard shortcut. So if I were to start typing, say here, I just wanted to be a little bit more explicit with what this x = x + 1 is doing, I could say increase x by 1. And then if I hold Control and hit Q, it's going to automatically turn that entire line into a comment. This is also useful for more than just adding comments to your code. Say I accidentally had an additional drive distance here that I wasn't sure if I needed it to be there. I could go and hold Control and hit Q to comment that line out, and now when I run the program, it's going to completely skip over that and move on to the next line. So it's a really easy way of quickly testing if we need a line or not, or maybe adding in something just to print out some values for me temporarily. So another way that we can utilize ChIDE to better build our programs, especially with these debugging features, is through what we call breakpoints. So breakpoints are little flags that we can put in the editor here that would notify the debugger that we want to pause at that line so we can see exactly what is going on. To add a breakpoint, you can just put your cursor on any line of code. So for example, line 21 here, if I wanted to pause and see what's going on, I put my cursor there and select break here in the top menu, and you'll notice a red circle appears in the column here with all of the line numbers. That indicates that if we were to run the debugger, it would pause at this line for us to see it. Another way that I could add breakpoints is by just clicking where this red circle would be, and that would add or remove it. So if I wanted to break at every single drive distance here, I could just click to add a circle on each of those drive distances. So if I just keep this one breakpoint, to use these breakpoints, all I have to do is click on Start here in the top left. And this is going to start debugging the program from the beginning, and it's going to run through everything all the way up until it gets to that breakpoint. And you'll notice it's the third drive distance that I have the breakpoint on, so it'll get to this point and then it's going to pause. And you see it highlighted the line that I have the breakpoint at, and it outputs all of my variables here in the bottom left. So if I wanted to debug something 10, 20 lines down into my code, I could really easily use a breakpoint to run through to that point instead of having to sit here and mash the next button 20 times. Going back to my simulation here, I see everything's good and I want it to keep going, so I can click on the continue button and it will keep going until it gets to another breakpoint. Or I could click on the next button and it will go line by line again until it either reaches the end of the program, or I click on continue and it moves on to another breakpoint. So if I click next, let me move this off to the side here so you can see. If I were to click next, it's going to go one command at a time. See, it did that, and now it will turn when I click next. But if I want it to keep going until it gets to a breakpoint again, I can just click on continue. And you see it'll keep going through line by line. It finished that first square, and it's going to get halfway through this second square before it reaches another breakpoint. And then it paused at that breakpoint again, and I could keep it running right there. So I know now that I could use breakpoints to quickly navigate to different portions of my code using the debugger, again without having to press next 20 or 30 times. In addition, it could be a really quick way of seeing how just one line of code halfway through my program is modifying my variables, so I can verify that my logic there is correct. Now, I don't actually want to run this all the way through driving the square 5 times, so I'm going to go ahead and click on abort, and it looks like it's going to pop up that error that I was talking about. See, it's kind of frozen and it crashed. So if that happens, I can always just open up ChIDE again and it will pull back to here, and then I can just select the open and navigate to my code that I had written. And so here's my code again. So now that we've looked at breakpoints and the next button, let's start to explore a little bit of what this step function does. So this step function is very, very similar to next in that it runs through a single line of code. However, it will navigate into functions so that we can see how a function is handling something. So let's look at writing a quick example of a function. What if I wanted to, instead of use a loop here, I wanted to create a function for driving my robot in a square? I could say void, which means I'm not getting a value out of this function. And then I could say drive square, and then to add parentheses. And this is just me declaring that this drive square, whenever I use it, will tell the robot to drive in a square. Now, one of the reasons a function would be useful for this specifically is what if I wanted to change the distance, the length of the sides of the squares? I could declare a variable here and say double side, so that this side corresponds to the side length of my square. And then I can close my parentheses and I indicate the code for my function with a brace here. And once again, you'll notice the brace starts off red because it doesn't have an endpoint. So I'm going to go ahead and add the endpoint there. Then I'm going to go ahead and copy all of this code for driving the robot in a single square. And I'm going to do that with the Control-C and then paste it in here with Control-V. And I'm going to go ahead and I don't really need this line here, so I'm going to select it and I'm going to delete it because it's a comment. It's not really contributing to my square. At this point, every time that I were to call this drive square function, it's going to force it to drive 5. I could just replace all of these 5s with the word side, and that would update what I have there. So I'm going to go into search, replace. I'm going to replace the number 5 with the word side, and I'm going to replace only in my selection, and then close. So now I have my drive in a square function. That is taking the place of all of this code here, so I'm going to go ahead and delete it. And instead of typing in all of that code over and over, I could just type in a single function or a single command called drive square. Now, as I'm typing in drive square, you'll notice that it highlights and pops up underneath here. If I want to automatically complete what I'm typing, I can just hit the tab key, which is above caps lock on the left-hand side of your keyboard, and it will automatically complete typing in drive square, and I can open up parentheses and give it any parameters that this function needs. The side length of my square was 5 before, so I could say 5, and then I can end the command with a semicolon. Now, what if I wanted to drive in increasing size squares? I could instead say drive in a square of x. And then what it will do is every single time that x changes, it will drive in a square of side whatever x is. So a side 0 to start, and then 1, and then 2, then 3, then 4, and then it'll finish because it won't actually run through on 5. So just so you can see what this looks like, if I were to click run and run through this program, a square of length 0, the robot doesn't move, it just kind of spins in place over and over. Then a square of length 1, it increases and it drives in that square 1 inch, and it'll keep going until it finishes, and then it will increase once again here so that it drives in a square of 2 inches. And you can see here, this trace here of the robot is getting gradually larger. And so you can start to create some really neat designs with the robots and the tracers here in RoboSim. So I'm going to go ahead and pause this and close my simulator so that it stops the program here, because I don't need to actually show driving in a square 5 times. Now, if I were to click on the next button, this is going to start my debugger like we saw before, and I can click next to start the simulator. I'm going to once again drag it off to the side so that you can see here. And I'm just going to keep clicking next a few times until I get to my loop. And here at my loop, it's checking before running, and when I run it, it's going to say if I click next, it's going to run through everything for drive square. So here I click next, and if I unpause my simulation, it's going to run through everything for drive square, and then it's going to move on to the x is equal to x plus 1. Well, If I click next again, it's going to get to the drive square again. I could click next and it'll just run through the whole thing. But what if I wanted to debug something inside of this function? If I were to click step, it's going to tell the debugger to step into the function and let me see line by line what is happening here. Now, I do recommend using step only when you want to dive into your own functions. Some functions, if you were to try and step into them, you'll get into some pretty confusing lines of code that are a little bit more advanced than we will be able to talk about. So it's really important that next it runs through the line here, and step is mostly useful for stepping into your own functions that you have created. And if I were to click next and keep going, it will run through this entire function here. And then once it's done with the function, it will return back. I don't have to click step again. It will just go straight back out of that to this x equals x plus 1. And each time I get there, if I don't click step, it will not step into the function. So it makes it really, really easy to start to navigate through your code with this debugger. So let's talk about another way that ChIDE really helps out as you're building programs. I'm going to go ahead and abort this again. It's going to give me that error, I think. Yes, it is. That's okay. I can reopen that once again. And robot square. So another way that ChIDE really helps us out is by creating shortcuts for a lot of our functions. For example, if I wanted to add an additional motion for the robot so that instead of just doing squares all starting at the same corner, I could have it offset those squares. So I would want to drive the robot some distance again before repeating the square. So I could say robot.drive distance and type it all out. However, another option is to just type the function name, drive distance, and then hold Control and press B on the keyboard. And this is our kind of universal autocomplete. It's for all of our pre-built abbreviations to automatically type in, finish out whatever function it is that you are working on. So drive distance is already defined as a function, so when I hold Control and hit B, it auto-filled to robot.driveDistance, and then it tells me a name for the parameters, and if I had a variable for distance, it would just use that variable. So I could say drive 2 inches, and then use the radius that I have here, and then if I run this, it's going to do the exact same thing, but instead of all of the squares starting with their bottom right corner here, it's all going to be shifting up by 2 units each time. And you can see this one moved up by 2 before doing the 1 unit square, and then it's going to go up by 2 and do the 2 unit square, and so on. So I'm going to go ahead and stop this so that you can see a little bit more of this. So how do we know all of the different pre-built abbreviations in ChIDE? If you go up to the options menu here, and about halfway down the page, we have a button called Open ChIDE Global Abbreviations File. And if I open that, it's going to add a new tab to my IDE, and it's going to open this really long and exhaustive file of different definitions of abbreviations. And the way this file works is any line that starts with a pound symbol or a number sign is considered a comment. So it's a little bit different than a C comment because this is just a definitions file for us. And then what happens is every single time that it's defining something, you put whatever text you want to be the preface of the abbreviation or the abbreviation on the left-hand side of an equal sign. And then what you want it to fill should go on the right-hand side of the equal sign. So for example, if I were to type com, hold Control and press B, it's going to fill in this text here, which is for a block comment. And then this pipe bar here, this vertical line, marks the position where your cursor or caret will be after it fills in that text. Let me show you what this looks like. So if I go back to my robot square and I type COM, hold Control and hit B, it's going to automatically fill in with that text, and then notice my cursor is now right in between those two asterisks there, right where it was in my abbreviations file. And then I can start typing my comments right away. That's pretty cool. So if we were to look just briefly through this ChIDE abbreviations file, you can see that there are several hundred pre-built abbreviations for all kinds of different applications, like including different libraries like our plotting library, our LinkBot library, our Arduino library, for creating macro definitions, for running through if statements or else if or for loops or while loops, for starting to use arrays, for different macros like pi. So for example, if I wanted to use the pi variable, I could just type pi, hold Control, hit B, and it will automatically do the m_pi. And so you could go through and look at all of these different definitions here and see exactly how universal this shortcut is. Now that's not even all of the cool things about this, because once I've kind of seen all the different shortcuts that I have available, what if I wanted to create my own? For example, there's no shortcut yet for drive square. If I were to start typing drive square and hold Control and hit B, it's not going to autocomplete for me. But what I can do is go in and start to define my own abbreviations, and I do that by going into the options menu and selecting Open ChIDE User Abbreviations file. And this file, it includes all of the details about how to create a abbreviation here at the top, with a little bit more information about, for example, creating a homework template. If you were to type HW and hold Control, hit B, it's going to automatically fill with this type of a template here. Let me show you what that looks like. If I go to the top, HW, Control B, and it automatically fills with all of that information, which would be really useful for the top of each file that you have your students create. So back to the user abbreviations file, there's a few other abbreviations that are already set up in the user abbreviations file, and you can start adding your own abbreviations in here. I personally like to go down to the bottom and put in another comment saying my user abbreviations, and then I can start defining my abbreviations here. So if I wanted to do drive square, I could say drive square with a capital S, and then I could put the equal sign and then just type in the code that I want it to fill in. So this is drive square and then parentheses, and then the side length, close parentheses, and hit semicolon. Now if I were to do this as is, it would fill in exactly this. In order for that to work, I do have to save my abbreviations file, so I'm just going to click Save. And now when I go back to Robot Square, I have my drive square here at the bottom. I can hold Control, hit B, and it automatically completes to that drive square side length. But notice my cursor is here at the end afterwards and on the same line. So what I might want to do is go back to my user abbreviation and say I want to put my cursor right before side length, so that I know that I might want to actually add my own side length there whenever I'm calling this function. And then in addition, I don't necessarily want it to keep all of this code on the same line. I may want it to use enter at the end of the line so that I can easily start to separate my code and structure it for really easy reading later on. So I can add a \n to the end here, which is our escape character with our n, just like we use in the printf function, and that will tell it to add a new line at the end of, or right after this semicolon. So if I save it once again, go back to robot square, and say drive square, control B, notice my cursor is now here, and it added that empty line at the end here so that it would very easily start structuring the rest of my code. That would also make it easy for creating other templates, for example, for your students to use. If you wanted to adjust this homework template at the top here, you could go back to the user abbreviations file, and let's say you wanted to add another line for your group members, for your students' group members, and they just list other students in the class. In your abbreviations file, you could go into this and just scroll to the right on this homework is equal to line, right? I went actually a little too low. It's a little higher up. This homework equals to, and then I scroll to the right until I find, oh, it doesn't want to scroll. I might have to use my arrow keys here. I keep scrolling to the right until I find the point that I wanted to add it. So I have this new line character here, and then it ends, and I wanted to add it right after author. So I would just start typing here, the asterisk, group members, colon, and then I want to make sure that it adds a new line at the end as well. So then when I save this, I have now updated my HW abbreviation so that when I do HW, hold control and hit B, it automatically fills to autocomplete all of that. So it makes it really, really easy for us to start building much more complicated programs without having to do as much of the manual, tedious typing that we normally would. One last thing that I do want to show you before we end for today and open the floor for any questions is that you can export all of this code in a nicely formatted document that you could include in a Word document that you could upload to Google Docs, for example, and just allow students to view. You could put it into a PDF. So if I want to export all of this code, I can go into the File menu at the top, select Export from the menu here, and you can see that we have a bunch of different templates that you can export it in. We have HTML, RTF, PDF, LaTeX, and XML. If you wanted to do this, for example, putting on a website or something like that, you would want to export it as HTML. If you want to put in a Word document, which is called rich text, you would use RTF, which is rich text format. You could export it as a PDF, which could be opened in any PDF viewer. LaTeX is a more advanced templating language for text documents. You could export it as LaTeX as well. And then you could also export it as XML, which is similar to HTML, but without the hypertext and all of the other features of HTML with it.